Vasoconstriction is the narrowing of the blood vessels by the small muscles in the walls. This results in the blood flow to be slowed where less heat would be lost. Vasoconstriction is the opposite of vasodilation, where the vascular endothelium cells tightens the muscles, contracting the arteries and arterioles. End result, the flow of blood will decrease and the blood will be further away from the skin. Therefore, less heat will escape and the internal temperature will remain relatively the same. So why is this all important? If the penguins do not restore its temperature to its core temperature, then there are obvious detrimental consequences. For example, if there is a disruption in either of the negative feedback loops, then the penguin will suffer from hypothermia or hyperthermia. If the penguin fails to correct these changes, it can ultimately lead to death. Hence, the obvious adaptive advantages of thermoregulation in penguins is that they are able to survive in constantly changing environments. Chinstrap penguins sometimes migrate for mating. However, they do not migrate long distances to avoid extreme climate change. As a chinstrap penguin is well developed, they are able to stay in the same habitat despite extreme temperature fluctuation. Through this, the chinstrap penguins are able to conserve energy and time, which could be used for other important factors such as reproduction, more feeding time, and incubation for the chicks. Also, as there are abundant amount of prey near the South Sandwich Islands and Antarctic Peninsula, the thermoregulatory system they have allows the chinstrap penguin to live in the sub-Antarctic region where there are plenty of food. End result, there will be no need for chinstrap penguins to migrate to find more food supplies or avoid climate change. The feathers of chinstrap penguins are a very valuable function for keeping them warm. They do not have large flat feathers like flying birds, but they are short with an underlayer of fine woolly down. They overlap and give a good streamed effect in the water, and an excellent wind sheeting abilities when on the land. This is important for the penguin's survival in water, and also the constant cold temperature. Air are trapped under the feather, which provides around 80% of the thermal insulation. The pillar erection of feathers is when the feathers involuntarily erects as a reflex to counteract of the feathers in order to trap more air and prevent heat loss. When it goes too hot, they flux their feathers of the trapped warm air to escape. However, there is a feather loss disorder, where penguins do not have any feathers or produce any feathers. This decreases their survival chances dramatically. They are no longer able to rely on their feathers for pillar erection and thermal insulation. Therefore, maintaining thermoregulation, they need to rely on other responses such as vasoconstriction or increasing the metabolic rate. Featherless penguins will grow slower and smaller in size and weight compared to those with feather. This is because more energy is required on keeping warm, as there is an absence of insulating coat of feathers. In conclusion, the chinstrap penguin regulates its core temperature of around 37.5 degrees Celsius. Hypothalamus detects the change in internal body temperature of the chinstrap penguin. To return and maintain back to optimum core temperatures, the effectors such as vasoconstriction, vasodilation, panting, shivering are used. Overall, Homeostasis and thermoregulation allows the Chinstrap
created using Powtoon.